All right. Let's talk about scale drawings. First of all, we need to know what a scale drawing is, okay? A scale drawing is a two-dimensional a scale drawing is a two-dimensional drawing that is similar to the object that it represents. A scale model is a three-dimensional Okay, a scale model is a three-dimensional model that is similar to the object it represents. So a drawing is obviously that. It's a drawing of a house or a map. Okay, there's many different things that they use scale drawings for. A scale model would be like up there on top of my cabinet, the scale models of our churches that we did a couple of years back. Those are scale models. We had to have a scale drawing to make the models. Okay, and so two different ways that we can show larger things in a smaller sense. Okay, to do that, you must have a scale. Okay, a scale gives a relationship. Usually in ratio form between the scale model or drawing and the object it is similar to. Okay, so the scale tells us, for example, you've seen them, I'm sure quite often on any kind of map. Okay. In fact, let me see real quick here. Yes, Anthony. I guess. Okay, these are all scale drawings, obviously, of different types of things. That looks like the the man-moon lunar ship that they landed on Mars. Okay, you have all different types of things here. Helicopter. Okay, if you go there, you can see. Okay, how they're giving you the different measurements on the helicopter. Obviously, that's not the size That's not the size of a regular helicopter, obviously, because a regular helicopter obviously would not, take up the screen obviously more than that. So that's your typical scale drawing would be, let me go to this one. Okay, there's a good one there. That's of a bathroom. Okay, it's somebody, obviously doing some work in their bathroom, so they're drawing a scale drawing. But the thing I want to look at is the scale. Okay, the scale on the bottom says 1/8 inch equal 1 foot. Now, obviously, they've done that on their own. A lot of times when you see scale drawings, they'll be on graph paper or big sheets of graph paper, where one of the squares equals a foot or one of the squares equals 6 inches. But that's one. And then also, let me look here. Okay, you have to have scale models of airplanes, okay, because everything that is built, this building that was built, anything that has been built started off as a drawing or as a model, okay. For example, when they do a car, when they build a new car that they've never built before, now let me show you one more. I saw one here. Okay, it's hard to read down there at the bottom, okay, but that says scale is 1/4 inch equal 1 foot. Okay, so every 1/4 of an inch equals a foot on that particular floor plan of a house. This is where you see it a lot in just the general people that look at floor plans or scale drawings. This is a scale drawing called a floor plan, and it basically outlines how a house is going to be built. Okay. It even actually tells you, okay, like this in here is telling you that's going to be a window. Okay, so it's not just, hey, let's put a window here and a window here. It's actually planned out on the drawing for how big the window is going to be. All of those nuances. You have closets. You have where they're going to hook up water for the dishwasher, for the washer and dryer. And so all those things are planned out before it's even built. This school here, all the floor plans, I think Mr. McDaniel told me there was over 225 different floor plans for this school that they had to follow. I mean, it's literally, they roll it up, it's about this long. It's about this long and about this wide when you actually hold them out unrolled, but you roll them up and he's got like 10 rows that are about that big. And all it is floor plans, because they have floor plans for electrical. They have floor plans for the air conditioning, heating system. They have floor plans for walls. They have floor plans for, where the plugs are going. These plugs were not just stuck. They weren't just, hey, that's a good place, let's cut a hole here. If you actually look, this plug and that plug and that plug are right across from each other, they're equal. Okay? And it's the same thing on the other side. So they have to plan all the electrical. They have to plan, the whiteboards here and here weren't just stuck there. They're a certain distance from each window in every single room. Okay? So that's what a floor plan does. It takes the little small details of a building, in this case, or of a building project, whether it's a house, school, car, even, something as small as a lamp. Well, they actually have scale drawings for the lamp that's being built. Something like that at my projector. There's a scale drawing for that projector because they got to know where every single connection goes. Every wire's got to run in a certain place. And all of that, they come into it. And so probably scale drawings and scale models are probably the most commonly used thing that we talk about in math. And they do it everywhere. Nicole? Do you have a question? Yeah, oh yeah, it takes a while to build a house because there's obviously certain levels. There's the the foundation, then the framing, then the walls, then you have to go inside and, spruce everything up. And I think for this building, it ended up taking, I think it was 2 years it took to build this building. And it was, it was a very long process, and, it's not something that's real easy. I mean, you can make it easy, but then the thing would fall down after, 2 or 3 months. So obviously you wouldn't want that. Haley?
Isn't it called a blueprint? Yeah.
Sometimes they're called blueprints, yes. Yeah, they're called blueprints, floor plans, scale drawings. A lot of people really in the architectural world, I don't know if they use scale drawing as much as they use blueprints or floor plans. They use that more probably in the architectural area. Coach Jones that teaches art for us, he's got an architectural degree, and so he's actually done all the scale models, the scale drawings when he was working in that industry, and he also has an engineering degree, which a lot of architects are engineers as well.
He's an engineer?
He has an engineering degree, yeah.
So he could be an engineer if he wanted to?
Yeah.
That's cool.
Okay, so those are some examples of floor plans. Now, if we're looking for, if we go up here and we look for, instead of scale drawings, we go models. Okay, so to here, for example, that, okay, so obviously that's a scale model of, could be a hotel, probably more than likely it's condominiums, townhomes, things of that nature. But that's an example of a scale model. There you actually have, that's an actual scale model put on the floor plan. So it's the three-dimensional part of the house put on the floor plan of the house. And so they've gone in and said, okay, this is what we want the outside to look like. And it's, down to every detail. They're going to, like right here, they have these openings in the roof to show you, okay, this is what it looks like on the floor plan. Here they've got the opening in the roof and in the side, but you can tell they've got all the windows in place. They've got different shutters. Everything is planned out to the least detail. Do what? Yeah, it does. It has the measurements on there. This area down here, they're drawing. What that is that's like stairs up to that level of the yard. You've got things right here. This is probably a patio with different type of whatever planters maybe. But it looks like it probably is the back. And so that's another area of a scale model. It's a very interesting, I think it's a very interesting industry. Now, what I do want to show you that you can readily see a bunch is when we look at the models, okay, and what they've done with these scale models, and you can actually see this when you go to like Mason or the Hobby Lobby store, Michael's, where they have scale model replicas. And on the box, it will actually say 1/7 equals 1 foot or 1/8 equals 6 inches. And so what they're telling you is this, that if you were to measure, like for example, you were to measure these tires, okay, and you use the scale that's with the model, this tire would be the actual size of a real tire on a real, this is a Corvette, looks like, probably no, it's Aston Martin. And so that seat, okay, if you took the dimensions of that seat, and let's say it was 1/8 equals a foot, okay, 1/8 of an inch equals a foot. You take how many inches that is and multiply it by 8/1, that will tell you how many feet it would be on the normal car. And it would be even, they precise it down to like the turn indicator on the steering wheel, okay. And so that would be a typical scale model that you can go into the store and buy and put together, and it's going to be a replica of the real thing, okay? And so another example of a scale model, scale drawing, all right? And they'll have a drawing that comes up with that. They don't just, say, oh, okay, let's make it this size, and all of it's planned out. It's not just thrown together. Now, most of the time nowadays, computers do a lot of it for you. It used to be all by hand, and so that would obviously be hard to do. Okay, so those are some examples of what we're talking about when we say scale drawing, scale model, and the scale. Okay, now let's look at some actual problems dealing with scale model and scale. For example, look at page 302. It says a map has a scale of 1 centimeter for 5 kilometers. Okay, it has 1 centimeter for 5 kilometers. So the scale then is 1 centimeter over 5 kilometers. That's our scale. Obviously, the top number here is the dimension on they use a map here, on the map. Okay? The bottom figure is the actual distance, okay, in real life. Okay? So they're saying 1 centimeter on a map equals 5 kilometers in real life. Okay? Now what they want you to do is they want you to figure out, okay, so let's say that something is 6 centimeters on the map. Okay, it's 6 centimeters on a map. They want to know what it is in real expectations. Okay, so you set it up with the scale 1 over 5. Okay, once again, this is kilometers and this is centimeters. So we know that it's 6 centimeters on the map. So I have 6 centimeters on top. Okay, because that's where my other dimensions on the map are. So I have 6 centimeters on top. What goes on bottom is the x, because we don't know what the actual distance is if it is 6 centimeters on a map. Okay, well now we just use cross multiplication to solve it. We multiply across from bottom to top on both fractions, and so that gives me 1 times x is equal to 5 times 6. Okay? Now, in realistic terms, here's what you've got. Let me rewrite that with all the labels in there. You have 1 centimeter times x kilometers equals 5 kilometers times 6 centimeters. Okay? Now, let me put that 5 needs to be in the parentheses. Okay? Well, if you multiply this out, that's 1 centimeter x kilometers equals 30 kilometers / centimeters. Okay, well, when I divide to get the centimeters off, I divide over here as well. Centimeters cancel out, leaving me with kilometers. And so that gives me x is equal to 30 kilometers. Now, I do all that, just solve it. And then if they're wanting the actual distance, it's in kilometers. If they're wanting the scale distance, then it's in centimeters. And that would just be x is equal to 30 kilometers. But that's why it's kilometers. That's how the labels cancel themselves out. Okay, and so that's your answer on that. Fairly simplistic problem. Okay, we're going from the scale to the actual. We're going from the drawing to the actual. Okay, so let's look at one. It's not quite as easy. Let's see here. Let's go with 0.6 centimeters. So I have something that's 0.6 centimeters on the map. Okay, well, my ratio is the map over the actual. Okay, so that means I have 0.6 centimeters here, and I have the unknown there. So we cross multiply, and that gives me 1 times x is equal to 0.6 times 5. .6 times 5 is 3.0. And obviously that is kilometers. Okay. Now, 1 centimeter is pretty small. I don't think I have a centimeter ruler out, but it's pretty small. So obviously this is a map of some pretty big distance. And let's say, you got a map like that big. Okay. But obviously, 6 centimeters is not real big as far as, actual map. So it looks like they're probably dealing with a map that covers a large area. Okay? So those are fairly simplistic. What if they want to go the other way? Let's say they have the actual and they want to go to the scale or the map. Okay? The next set says a map has a scale of 1 inch to 3 kilometers. Okay, 1 inch to 3 kilometers. Then it says use the given actual distance to find the distance on the map. So now they want 1 inch equal 3 kilometers. Okay? Now this is your scale for the map. So now what they're saying is, okay, I've got something that's 90 kilometers in actual distance. And I want to know what it is on the scale. Okay? So that means I take my scale, 1 over 3, and I'm going to set it equal to, remember this is the actual, 90 kilometers is the actual, so I got 90, and I want it over x. I want it under x, because x is the map distance that we're missing. Okay? So same thing here, same thing we've been talking about for about 3 weeks now, just cross multiply. 3 times x, and that's equal to 90 times 1. 3x would be what? 3x. 90 times 1? 90. Go 3 into both of them, means x is equal to 30, so it's 30 inches on the map. Okay? Now, you can run them either way. Yes, in other words, I can do this one is 3 over 1. I just have to make sure it's 90 over x. I just have to make sure that right there is the actual and that right there is the scale. Okay, you just have to make sure that both those numbers are on the same. Okay, so if let's say I had 14 kilometers. Let's say the actual distance is 14 kilometers. Okay? That's how far it is to, I don't know, somebody's house. 14 kilometers. And I want to know on the map how far that should be. Okay? Well, then you just simply go here, and my ratio is 1 over 3, so it gives me x over 14. Okay? Once again, this is my actual, and this is my scale. So if you cross multiply that, 3 times x, 1 times 14, so it's 3x equal 14. So once again, we divide by 3. X would be equal to need to have your label, 4 2/3 inches. Then they're going to take it a step further, and they're going to want you to write the scale without the units. Now, basically what they're saying is this: 1 inch colon is equal to 10 yards. Now, what they want you to do is you can't take the labels off of that and know what the 10 stands for, okay? Or realistically the inches. So what they want you to do is they want you to express it as a scale, but they want it in the same units of measurement, okay? So they want us to convert to the smaller unit of measurement. Okay, they want you to convert to the smaller unit of measurement. Okay, so which is smaller, inches or yards? Inches. So I got to convert the 10 yards to inches. Okay, now remember that I believe, let me see, I think it's in this book, yeah. On the back cover of your book are the, how many inches are in this and all that. Okay, kilometers and all that is back there as well. So, if I'm converting this, I need to convert 10 yards to inches. So I have 1 inch over here. There is how many feet in a yard? 3. Okay, 3 feet equal a yard. How many inches are in a foot? 12. So how many are in 3 feet? 36. So there's 36 inches in 1 yard. So we have to multiply. No, by 10. We found out this is how many is in a yard, so now we multiply it by 10. What? Yeah, 360 inches. Now, they want it without labels, so it would just be 1 colon 360. Now, if that was just written down somewhere and you didn't know the background behind it, you would not know you wouldn't want it without labels. Because that could be, 1 centimeter, it could be anything. Okay? And so, but for right now, they want you to express it, and what they're basically saying is convert the scale into the same unit of measurement. Now, if you did run across something like that, where they just had 1 over 360, and let's say the problem 14 was 2 centimeters, okay, then you would have to assume that this centimeters is what that is in. That's what you would assume, okay? If they gave you a problem and they didn't give you what the label was, you would assume whatever the number they've given you with the label is what your information is in, okay? Now, let's look at this one. 1 centimeter colon 5 kilometers. Now, this one's a little tougher, okay? If we think of kilometers, then you have hectometers, then you have decameters, then you have meters. Well, they want us to go further. Then you have decimeters, that's a little d. And then you have centimeters. Okay, so they want us to go from kilometers 1, 2, 3, 4, 5 places back. Okay, so that means you have 5 with 5 zeros after it. One centimeter is equal to 500,000 centimeters. Okay, and that means 1 colon 500,000. Now the last one here is millimeters. Okay, so if we went all the way back to millimeters, then it would be 6 zeros. Huh? Yes, this is your answer right here. Now, if it was 1 centimeter colon 2 meters, Well, you're going from meters to centimeters. So you move 2 places to the right. So that means I add 2 zeros to my 2. So that'd be 1 centimeter colon 200 centimeters. So that'd be 1 colon 200. Okay, that's your conversion right there for the metric units. And that's your main one. That's hectometers. What? Right here. I went 2 places to the right. So I take 2. The decimal would be right there. And so I move it once, twice to the right. And so I have to add 2 zeros there. Been a while since we've talked about the metric system. Huh? Yeah, and if you if you have to go back this way, then you're moving it to the left. The decimal moves to the left. But you won't have to go back that way if you're converting to the smaller unit of measurement. Like if I was going to change centimeters to kilometers, then I would have moved it to the left. Then that number, five places. Okay. Okay, let's look at this one. Number 36 says, in a scale drawing, a wall is 8 centimeters long. The actual wall is 20 meters long. Okay, find the scale of the drawing. So it's basically 8 centimeters over 20 meters. Okay, well I have to convert meters to centimeters if they want the scale. Okay, so if they want the scale, then I would do this. You'd have 8 on top, and I want to go meters, and then you have decimeters, and then you have centimeters. So I'm going to go once, twice to the right. So I'm going to take 20 and go once, twice to the right. So that's 8 over 2,000. Now I have to reduce it. Okay? 8 will go into 2,000. 8 goes into 8. I'm going to divide by 8. 8 goes into 8 one time. 8 goes into 2,000 250 times. So my scale is 1 over 250. Okay, your homework is 6.6, and we're going to go 12 through 38. No. Let's go. Yeah, I'm going to have to. 12 through 38. Shouldn't take you that long if you understand the concept, hopefully. You may go